Okay, so let's talk about logarithms. So what we're trying to do in order for us to solve these is we're trying to condense it down and make it something where everything is just in one or two logs, okay? So, of course, we want to make sure that we have our rules nearby so that way we know what we can and can't do as far as our shortcuts. So let's take a look at this first one. Here I see that I have separate logs. So I know that my rule is if I want to have two separate things like I do there, I can combine them by multiplying them together. So I'll go over here and I'll multiply what's in here times what's in here. Okay, so now that I'm here, I can go ahead and I can try to solve this because now I have it all in one log. Now, whenever I'm doing log, that's always in base 10. So this is a 10 down here. Meaning 10 to the power of 2 is equal to this. Now I'm going to go ahead and I'm going to separate everything out. Now, of course, anytime I'm trying to solve an equation, I want it to be set equal to 0. So, I'm going to go ahead and move that 100 over. Now I'm going to go ahead and see if I see anything in common among these. I don't. So what I'm going to do is I'm going to attempt to factor this. Now, so let's back up a little bit. Anytime I have a quadratic equation, it's always going to be written in standard form. It's going to look like this. So I have to go back over here and I have to look at this and I say, okay, A is going to be equal to 1. B is equal to 48. And C is equal to negative 100. I'm going to multiply A times C. And I need two numbers that when multiplied together will give me negative 100, but when added together will give me positive 48. So I don't know what the numbers are, so I'm just going to start at the beginning. That's not it. And there's my numbers. So I found them. Now I'm going to take this equation and I'm going to copy down everything except the middle one. I'm going to split the middle one into these two numbers. Notice that this stays exactly the same because positive 50 minus 2x is going to give me positive 48. So now I'm going to go through and I'm going to factor just in the beginning. So I see they have an x in common. Now I'm going to go and I'm going to factor just the second two. I see that they both have a 50 in common. Now, make note that the inside for both of these is exactly the same. Because it is exactly the same, I can combine like terms. Now, in order to solve this, I need to get them separated. Because they are multiplying, I can divide by each one. And I get each one as a separate equation. I can do the same thing by dividing by x plus 50. So I'll go ahead and solve it. There's one. I'll solve the other one. There's 2. Those are my answers. All right, let's look at the next one. So here we're doing natural logarithms. And again, the same exact rules still apply. So, what that means is I can take these and combine them by multiplying what's inside of the natural log. So I'll copy down my first side. I'll put in my natural log and I will multiply 2 times everything that's in there. Now I'm going to go ahead and I'm going to simplify this a little bit. Now, because I have a natural logarithm on both sides that is equal, I can take them out of the natural logarithm. I'm going to go ahead and collect all my like terms. I'm going to put all my x's together. And now I need to do exciting move, great divide to get my x by itself. I'm going to divide by 5. And, whoops, based on this, I find out that x is equal to 2 over 5. All right, let's look at the next one. So this one, of course, they're trying to trick us a little bit. They didn't quite write it the way that we want it to. So I'm going to go back and look at my rules. So there's a couple of different rules that we can use for this. But I think probably the easiest one is to look at the fact that both of these are 2 to the power of something. So I'll leave this one the same. And I'll figure out 2 to the power of what is equal to 128. So 2 times 2 times 2, there's 8, 16, 32, well, so 2, 4, 8, I'm just multiplying by 2, 16, 32, 64, 128. So I did 2 to the power of 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7. So that means 2 to the power of 7 is the same thing as 128. So I'll write that in. Notice, again, the same exact thing applies. Because my base is exactly the same, these guys up here have to be the same as well. So 3x minus 1 equals 7. I'll get rid of this 1. Divide by 3. And there's my answer. All right, let's look at the next one. Same exact thing here. However, because they put a bigger number than 2 here, and I have stuff up here, it's just going to multiply, okay? So, first things first, let me go back and reference this. So I see here that this is a 32. 32 is equal to 2 to the power of 5. I see this is an 8. 8 is equal to 2 to the power of 3. So, I'm going to write that out. 2 to the power of 5 multiplied by 2x plus 1 is equal to 2 to the power of 3 multiplied times x plus 1. Again, we have the same exact base, meaning that our exponents up here have also got to be exactly the same. So 5 times 2x plus 1 equals 3 times x plus 1. Now I'll go ahead and attempt to start simplifying this. Now I'm going to get all of my x's together. I see that I need to get my x by itself, so I'm going to move this 5 over, and I'll continue on this side. Divide by my 7 to get x finally by itself, and there's my answer. All right, let's take a look at this one. So here it is a log base 3. What does this mean? That means 3 to the power of something is equal to, 3 to the power of whatever's on this side is equal to 14. Now, there is also a rule. Let's see. Particular one, we can change out our base. So for this one, I can take the rule and I can break out these bases. Now this would be my exact answer if I didn't want to write it out in decimal form, but of course I'd have to use the calculator and it'd be approximately 2.40. Now this rule here is just simply whenever I have a base that is not 10, 10 is the one that we don't write in. Like here, this would actually be a little 10 here, we just don't write it. If we wanted to change that, we could change it just like I did here. So let's look at the next one. Here we have 7 to the power of x is equal to 10. So I'm going to take the log of both sides. Log base 10 of 7 to the power of x is equal to log of 10. Now, this of course becomes 1. And over here, because this is an exponent, I can bring it out. Now I'm going to go ahead and divide both sides by log 7. And I have my exact answer. If I wanted to plug this into the calculator, I could. And I would get approximately 1.18. All right, let's look at the next one. So here I see that I have log base 3, I have a minus 2, I got a lot going on here. So first thing I want to do is I'm going to go ahead and I'm going to get all of these logs on the same side. So I'm going to go ahead and move this one. I'm going to subtract it because it's positive right now. Now I'm going to go ahead and rewrite the entire thing out. Okay, now if I go back and I look at my rules, I see here that these guys are subtracting, they have the same exact base. So subtracting, same exact base here, right? That means that I can plug them into one log by themselves, dividing. I'm going to go ahead and move this 2 over. Now that I'm here, I want to go ahead and get rid of this log. So I'm going to say that 3 to the power of 2, because I take whatever's here, put this as my exponent, is equal to x plus 1, all divided by 2x minus 3. Now, 3 squared is 9, so 9 equals x plus 1 divided by x, 2x minus 3. And I can go ahead and multiply both sides by that. So over here I get x plus 1 because these guys are going to cancel. Over here I get 18x minus 27. Now, of course, I still have to continue to solve. I'm going to move my x over. I'm going to go ahead and move my 27. And I end up with 17x equals 28. I'm going to divide both sides by 17. And I get this improper fraction as my answer. X is equal to 28 over 17. Okay. So now I'm going to go ahead and I'm going to look at this quadratic equation. So, quadratic equations, remembering that they always look like this. Whenever we're looking at these, it is important to remember that this is going to tell me how wide or skinny it is, the number part. And if there is a negative, it flips. This number by itself will tell me my y-intercept. Okay? So, let us take a look at this in the calculator because it'll be a lot easier. So, I'm going to plug in an equation. Okay. Okay, so here we have an equation. So notice, whenever I have my a value equal to 1, it's opening upwards. Notice how it's opening upwards, right? Now, if I make that number bigger, notice how my graph shrinks up. It gets skinnier. It gets vertically stretched. Now, the interesting thing is, whenever I take this number and I change it to a negative, it's immediately going to flip upside down. So notice how it gets skinnier going that way too. So if I go from a -5 and start heading up, it gets a little fatter, little fatter, little fatter, and then eventually it's going to flip over and open back up. Stays a little fat, and then it starts getting skinnier, skinnier, skinnier. Okay. Now we're looking at the C value, the number that's by itself. Notice how if I move it up, the graph moves up. If I move it down, the graph moves down. Nothing else happens. It just moves the graph up and down. It does, however, change this y-intercept where it's going to be touching my y-axis. So notice, if I move this to 3, it should be touching at y equals 3. So 1, 2, 3. Okay. So here we've got to figure out a couple of different things. In behavior, vertex, axis of symmetry, roots, and y-intercepts. So let's start with the easiest one. Y-intercept. That's going to be the number that's by itself as long as it's written in this form. Y-intercept is located at 0, +2. So my in behavior, I'm going to look at this number. I see that it's negative, so it's going to be opening downwards. So I'll just set my graph here to -2 Notice how it's opening downwards and it's heading towards negative infinity for the y, because it keeps going down, and negative infinity for the x in this direction, positive infinity in this direction for x. So I'll say that this opens downward. Now, of course, my vertex, there is an equation for us to find it, and so is there for an axis of symmetry. So let's look those up real quick. So here's the equation for my vertex. So my x value for that is negative b over 2a. So negative b over 2a. So I see two negatives, make it a positive. So positive 4 over negative 4, negative 1. So there's my first value. Now I'm going to look for my y value. C minus b squared over 4a. So c minus b squared over 4 times a. And I'll simplify this, of course. So my vertex should be located at negative 1, 4. My axis of symmetry. So here would be my vertex, and actually let's go ahead and set up this exactly the way we see it. We'll go ahead and type in that equation. So this will be negative 2x. Oops. Negative 2x to the power of 2 minus 4x plus 2. This is what our graph looks like. Here is my vertex. Notice that it is located at negative 1, positive 4, just like we predicted. My axis of symmetry is going to be a line going directly through there. It is always x equals whatever the x value is here. So here it should be x equals negative 1. So, in other words, I take this and I say x is equal to whatever number there is. That is the equation of the axis of symmetry. My roots are going to be where it touches the x-axis. Here and here. Now, in order to solve for that, we can use the quadratic formula, or we can attempt to factor it. For this particular one, I'm going to go ahead and try and factor it. So I see here, first of all, that they all have a 2 in common. But because this leading one is a negative, I'm going to divide everything I see by negative 2. Now I'm going to do the same method I did earlier. So a is equal to 1, b is equal to 2, c is equal to negative 1. So I'm going to do a times c. I need two numbers that will multiply together will give me negative 1, but when added together will give me positive 2. So since obviously this one can't be factored like that, we can assume that it's going to have some kind of crazy numbers that are going to be really hard for us to find. So what we're going to do instead is we're going to use a quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. I'm going to use my original formula. So over here, a is equal to negative 2, b is equal to negative 4, c is equal to 2. So I'll go ahead and start writing that out. So negative 4 plus or minus the square root of negative 4 squared minus 4 times a times c, all divided by 2 times a. Let's go ahead and start simplifying. Here I see double negatives, positive. Negative 4 times negative 4, positive 16. 2 negatives make a positive. 4 times 2 is 8, times 2 is 16. Now I'm going to go ahead and combine those 16s. All right, so now I want to simplify this even further. I'm going to look at this guy. I'm going to break it down. So 2 times 2, well, let me do it the simpler way. So 2 times 16 So I broke it down to its factors. I see I have 2 4s. So I'm going to write this out one more time. So if they have a match, there's 2 of them, I could take 1 out. So 4 plus or minus 4 times the square root of 2, all divided by negative 4. So now I'm going to go ahead and break this apart. So 4 plus 4, square root of 2, all divided by negative 4. 4 minus 4, square root of 2, all divided by negative 4. So if I simplify, negative 1 minus square root of 2, and over here, negative 1 plus square root of 2. Those are my 2 answers. And if I plug them into the calculator, I would get negative 2.41, and the other one would be some positive number over here. Now, in order to graph these, of course, we could take a couple of different points. Typically, we like to always use our vertex as our starting point. So negative 1, positive 4. Y-intercept is 0, 2. And then I could look at any other points. I could plug in random x values into my equation and figure out what they are. But I'm going to cheat a little bit and I'm going to look at my table here. I'm just going to find a couple more values that are small. So negative 1, positive 4. Positive 1, negative 4. Negative 2, positive 2. Now, the great thing about these is that axis of symmetry is always going to go directly through my vertex. This is my axis of symmetry, this little dash line. And that means that it's always going to be a mirror. So here's this. Notice how these are mirrored. So I can take this point, mirror it across. And it should continue out. Now, of course, you may need to graph additional points to get it to look right. Okay, let's look at the next one. So again, here we have one that has a positive a value. Opens up. Because it's positive. My vertex, let's go back and find our equation. I'm going to look for it negative b over 2a and c minus b squared over 4a. So negative b over 2 times a, comma, c minus b squared, all divided by 4 times a. So let's simplify this first one. Negative 12 over 4, negative 3, comma, and this will be 10 minus 144 over 8. So my vertex is located at negative 3, negative 8. My axis of symmetry, I'm going to take this x equals negative 3. Now my y-intercept is going to be whatever the number is by itself. And of course, my roots are going to be my x values that I'm going to solve for. I could attempt to factor them. I could use the quadratic equation. So just to cheat a little bit to figure out which one we would need to use, I'm going to type in my equation here. And I notice that it does have x values that are whole numbers. So let's trace them. Let's see. So I do have a 0, negative 5, and negative 1. Okay. So I know for sure that I can use either one of them. I'll go ahead and just factor. So first thing I'll do is I'm going to rewrite my equation. I see that it does have a 2 in common for every single thing. So I'm going to factor out a 2. All right, now I'm going to go ahead and I'm going to use my different values. So A is 1, B is 6, C is 5. So A times C is 1 times 5, which is 5. I need two numbers that will multiply together will give me 5. However, they will add together to give me 6. So I'll start at the beginning, 1 and 5. 1 times 5 is 5. 1 plus 5 is 6. Those are my numbers. Now I'm going to take the inside of the equation and I'm going to split it apart into 1 and 5. Now I'm going to go ahead and I'm going to factor each 2 sets. So here I see, oops, forgot my squared. Here I see they both have an x in common. So I'll factor out an x. Here I see that they have a 5 in common. So I'll factor out my 5. I see that the insides are exactly the same, so I can combine like terms. Now, because they are all multiplying together, I can separate these. I'm not going to go through the math for that. But suffice it to say, I can just break it apart like this. And solve for x. There's my two roots. So here my roots would be located at -5, 0, and -1, 0. So I'll go ahead and I'll graph this. So first I'll start with -5, -1. I'll go ahead and graph my vertex at -3, -8, so -3, -8. There's my graph. If I wanted to, I could put additional points, but I'll just say it's approximately something like that. Okay, let's take a look at the next one.